Now, in everything that we have talked about in this section so far, we have known the population standard deviation, sigma. So that's been kind of the caveat for creating a z-interval. In practice, in the real world, if you don't know the population mean, it's very likely you also don't know the population standard deviation. So in those cases, so again, in more general practice, a lot of times you just simply cannot use the z-interval because you don't have enough information to do so. There is another type of interval called the t-interval that you must use instead. So in practice, in the real world, this is the one that you will more likely find yourself using. We've been practicing and building up to this with kind of the more simplified situation, but this is really the key to what most statisticians do. You still have to ensure when you're doing a t-interval that your entire population is normally distributed or that your sample size is at least 30. So that stands as well. Let's start a practice problem here, or start the idea with knowing the sample mean. Okay, we've taken a sample and we've got the sample mean and we have that information. We still will need to calculate our alpha value first. Then we will calculate the margin of error using the confidence.t function instead. Notice the difference here when we're doing a t confidence interval. We don't know sigma. We can't sub that in. Instead, we know S. We know the standard deviation of the sample. So no population information is known. Only the sample information is known. We have X bar and we have S from our sample. Then, once we find that margin of error, we'd use the same technique of adding and subtracting it to and from X bar. Again, you can use Excel at that step or do it by hand. So what we have to do in Excel is part 2. Let's look at an example. The weights of running shoes are normally distributed. Oh, that's nice. We have the information that the whole population is normally distributed. So we're automatically good to go for either a z or a t interval. But we don't know the population mean, so we don't know mu, or the standard deviation of the whole population. They take a random sample of 23 shoes and they get a sample mean of 12 ounces and a sample standard deviation of 3 ounces. Use Excel to find the 95% confidence interval for the population mean. So why is it that we have to use the t interval here instead of the z? So notice we don't know sigma. That population standard deviation is unknown. So hence, can't use that z interval. We're going to use the t interval instead. Check the conditions. Are we able to? Yes, we already sort of did that. As I was reading, I noticed the whole population is normally distributed, which gets it. Notice they don't take a sample of at least 30, but that's not needed unless you don't know about your sample or about your population distribution. So we're covered with that. Okay, let's calculate the margin of error. That works the same way every time. You take the fact that alpha equals 1 minus the confidence level, 1 minus, in this case, 0.95 or 0.05. We have, in this case, we don't have sigma, but again, we have S being 3 ounces, and we have an in value of 23. Our margin of error this time is calculated by using the equals confidence dot t Excel command. That one takes the alpha value, 0.05, the S value of 3, and the in value of 23. So let's calculate that. I've got some other information over in my Excel for the next problem, so I'm just going to do it down here at the bottom. I'm going to find the NE for this problem. So that I just need to do the equals confidence dot t. So notice I have normal and t. We're using t this time. 0.05, 3, and 23 go in. My margin of error for this is 1.297. And now I can create my interval because I happen to already have x bar. It was given to us up here. So we can do x bar minus the ME, comma, x bar plus the ME, which is 12 minus 1.297, comma, 12 plus 1.297. That gives us a lower limit of 10.7. Oops. Oh, I kept more decimal places than I really intended to, but that's okay. I can go ahead and calculate that. So if we do 12 minus, sorry about that, 12 minus 1.297, then I get 10.703. I just had more decimal places than when I did it earlier. And if we do the 12 plus 1.297, then we get 13.297 as our upper limit. So watch for the rounding directions that you're given on your problems to make sure that you get those correct. Okay, and finally, for our last example, what if you aren't given the summary information for the sample at all? What if you don't have the X bar or the S, or the sample mean or standard deviation? As long as you have the data set, you can calculate those and move on from there. So this is kind of the longest type problem that you might come across. I'm still in that installs and delays Excel sheet, and I've clicked over to the delays tab this time. This time we have the sample for the number of flights delayed per month at a certain airport in a region. It says you're told the population is normally distributed, so that's good. That checks our conditions. I'm just going to say that checks it here, and it's good that we know that because look, the sample size is not 30 or more, it's only 20, but we check off our condition anyway. And we want to find a 99% confidence interval for the mean number of flights delayed per month. Again, why do we have to use a T interval here instead of the Z? Because we do not know, no information here was given about sigma. So we can't fall back on that Z, we have to use the T. Instead of being given the X bar and the S, we just need to go over here and calculate them. So in order to calculate X bar, again, I'm going to use that average function, and I'm going to see what Excel gives me. And in order to find the standard deviation, S, I'm going to use STDEV for standard deviation. And notice this is a sample, so I'm going to use the .s version. And I'm going to see what Excel gives me. So I've already got it set up over here. We want to find X bar equals average. Highlight your data range. Close it up and hit enter. Looks like our average is 315.75. So I record that. And to find our standard deviation, we're going to use equals stdev dot s. Same thing, highlight our data set. I'm going to keep just 2 decimal places here, so 51.73. Okay, so I've shown my Excel command that I'm using, and I've gotten my values there. I also need to calculate the margin of error, so that's the same way we've been doing that all along. We find alpha by doing 1 minus the confidence level, or 1 minus 0.99 in this case, which is 0.01. We have an S value now that we have found of 51.73. And our N value is, they didn't tell us that, so we actually just have to look. We have to know what N stands for. N stands for the sample size, and what I said earlier was that that's 20. So a margin of error is calculated in this case by doing the equals confidence dot t command with the alpha value of 0.01, the S of 51.57, and the N of 20 entered in. So I'm going to go over here to my Excel again, equals confidence, and I keep typing it in correctly. Confidence.t, put in those values. I'm going to keep 2 decimal places here again. That doesn't, let me see. Let's make sure I typed everything in correctly. .01, 51.7. Oop, I knew I typed in something wrong. Did you catch it before I found it? I typed in 51, and I wrote it wrong everywhere. It should be 51.73, not 37. So I'm going to change that here. This is 51.73. I just had a accidental mistype there. Okay, that should be good now. Okay, that's what I expected. So 33.09. But I do that too. I'm not immune to these kind of tiny little mistakes, and this is why I insist on you turning in your work, so that if you just reversed those numbers or typed in something slightly incorrectly like I just did, I can catch that and I can give you credit for all of the right stuff that you did do. And now that I've got this information, I can calculate this interval. So I've got my X bar value now. My interval is going to be 315.75 minus 33.09 for the lower limit, and then 315.75 plus 33.09 for the upper limit. And that gives us 282.66, comma, 348.84. So that is the longest type of problem that you may have to do when you are given absolutely no information about your population, and you also are not given any of the needed summary information from your sample when you have to calculate it all from scratch.